Speaking of Simon, this is our rough schedule for this evening. We got Simon Ritter coming up for about 10 minutes. And then he's going to be talking about OpenJDK and best practices. And then our very own Chris Curtin, who all of you probably know. He's been part of our JUG community forever. And then David Morris, Summers Pittman, who is actually an Atlanta JUG board member. And then Abhishek Mishra from OneTrust. So without further ado, I will stop sharing and we will kick things off. I know we're a little behind schedule, but that's fine. We got plenty of time tonight. Where do I stop sharing? All right. So Simon, go ahead and share your desktop and take it away.
Okay. Somebody needs to make me some sort of, give me some kind of permission.
Doing it now.
Thingy, whatever.
If I can make you, Vince, can you, or Vince or Glenn, can you make Simon co-host? It looks like I handed the baton over to somebody and I can no longer do that for some reason.
Yeah, I'm out. I can't do it.
Oh.
Vincent, hello.
Oh, hang on. I've got it now. Yep.
Okay, there we go.
All right, good.
We're good. Okay, right. Since I only have 10 minutes, I will get going. Yes, so I am Simon Ritter. I am the Deputy CTO of Azul Systems. We now have a nice shiny new logo. That was from last week. And I'm just going to talk very briefly about switching to OpenJDK and some of the best practices that we can do. Let me just fix one thing here. There we go. Let's just do that so I can actually see what's going on. Right. So first thing is to understand what we mean by OpenJDK. It's surprising to me the number of people who don't actually quite get all the nuances about OpenJDK. OpenJDK is the source code for the Java platform. It goes back to 2006, 2007, when Sun Microsystems decided to open source their version of the Java platform and make it available to people so that they could get involved in the development of Java. They could also look at the code and see what was going on and build it and do things like that. It's also, quite importantly, the reference implementation for the Java SE standard. And so if you go to the JCP, Java Community Process, each version of Java has a different JSR associated with it. And there is an expert group for that. I actually represent Azul on the expert group for Java SE. And as part of that, the reference implementation is OpenJDK. Now, the really key thing about OpenJDK is it's source code only, which means that if you want to use it to run your Java applications, somebody has to build it. And there's various different people that can do that for you. Oracle clearly are one that can provide you with a JDK. They have, in fact, two different versions that they can provide you. There's the Oracle JDK, and then there's the Oracle OpenJDK JDK. And then obviously there's people like Azul that can do that. Now, when you're thinking about OpenJDK distributions, there are a number of things that you should ask yourself in terms of what are the qualities of a distribution that you're looking for. And the way I kind of describe this is think about it like Linux. You know, Linux is an open source project. It's the kernel, and then people build distributions, Ubuntu, people like Debian, people like Red Hat, and so on. So what you need to think about is the distribution that you are considering using. First thing is what versions are supported. Now, with the way that Oracle changed things, they decided to go with long-term support releases. And again, that's a subtle distinction because Oracle's JDK was the one that started that, but OpenJDK doesn't have the concept of long-term support. There's different OpenJDK projects. If somebody wants to continue contributing to them, then they can do so for as long as they like. But long-term support is about the binary distribution and how long you get updates to that. So what you want to consider is which versions people provide support for. Now, lots of people are still using JDK 8. Lots of people have made the migration to JDK 11 because that's the current long-term support release, but certainly there are people out there who are still using JDK 7 for certain applications, even JDK 6, and I occasionally come across people who are using even older versions of Java. I think the oldest that I've actually seen somebody still using in production was 1.3, which is kind of scary when you think that there are people out there doing that. But I guess the thing is, if it ain't broke, don't fix it. So off they go. Secondly, how quickly do you get updates to that distribution? Now, the way that works is that Oracle will provide an update on a quarterly basis. So every January, every April, every July, and every October, there is an update to the Oracle JDK. And one of the things they do there is they release it, and people who also want to provide updates are not allowed to make their update available until Oracle have released theirs. There's a kind of contractual obligation, and there's a thing called the embargo, which means that once Oracle have delivered their update, then everybody else is free to do so at whatever point they want to do so. But the important thing is, how long do you have to wait for those updates once Oracle have released theirs? The key thing there is that security patches are included in that, and the release notes for that update includes all the details of the CVEs that have been addressed. That means that any hacker can look at those vulnerabilities and say, okay, if I can find an unpatched system, possibly I can try and attack it. So the longer you have to wait for your update to fix those patches, then the more time you're potentially exposed to those vulnerabilities. Second thing is, how long do people provide those updates for? If you want to continue using JDK 8, how long will somebody provide updates to JDK 8, or how long will somebody provide updates to JDK 11, and so on? So think about that in terms of the versions you expect to be using. Another key thing, are the builds that people are providing TCK tested? Now, I mentioned the idea of OpenJDK being the reference implementation of the Java SE specification, and each JSR for Java SE consists of 3 parts. The first is the actual specification itself. So that's the JVM spec, the Java language spec, list the class libraries. Then you've got the reference implementation, OpenJDK. And the third important thing is the TCK, which is the Technology Compatibility Kit. Now, technically, you should really refer to it as the JCK because it's the Java Compatibility Kit, but everybody refers to it as the TCK, which is a more general term for all possible JSRs. What that TCK does is provide, in the case of Java SE, about 100,000 tests, which you can run on a binary that you've built from source code, and use that to verify, if you pass all of the tests, that you actually conform to that specification. The nice thing about that is if you have a JDK that has passed the TCK and you want to move to another JDK that's also passed the TCK for the same version, then you're pretty sure that they're functionally identical, meaning you can take your application, you don't have to change any code, you don't have to recompile anything, just take your jar file, class files, and they will execute in exactly the same way functionally as they do on the other version. So TCK testing, quite important. Next thing, in terms of those updates, do you get just one update or do you get 2 updates? What do I mean by that? Well, if you look at what Oracle provide, and they do this for a lot of their different software, they provide 2 different versions of each update. One's called the CPU, the other's called the PSU. And in Oracle terminology, CPU is the critical patch update. PSU is the patch set update. Don't ask me how they came up with these names, and they're a bit kind of strange, but that's what you got. Now, the CPU is just the changes which relate to security issues. So it's only CVEs that have been addressed, small set of changes. The idea behind the CPU is that if you need to address a vulnerability very quickly, if you've got a 9.0 or a 9.6 or a 10 CVSS, then you want to roll those patches out as quickly as possible. And to do that, you want the smallest set of changes so that you've got the less or as little chance as possible of affecting the stability of your applications. The PSU is the whole update. So it's all the security patches plus bug fixes plus performance enhancements, any other code changes. Difference is that if you look at a CPU, there's probably somewhere between maybe 1 or 2 security patches. On a bad quarter, we might have as many as 12, 15. If you look at the number of changes for the PSU, it's in the hundreds. There could be like 400 different changes in a PSU compared to maybe 10 in a CPU. So there are chances where something can impact on the stability of your applications. A good example of that happened last year in July. We had an update that included a fix which actually broke things like Hadoop cluster, Solar, and Lucene. And if you'd had the CPU, you could have rolled out security patches and not worried about breaking your Hadoop cluster. And then last thing is traditional support if you want somebody that you can actually call up and say, I've got a problem with Java, who are you going to call? Don't answer that question. Right. In terms of what we do, I will just answer all of these questions in terms of our provided support and so on. We have Azul Platform Core, as it's now called. It used to be called Zulu. And essentially what we're delivering there is a build of OpenJDK. We have two things that you can get there. One is the free version, so you can just download it from our website. It's under the normal GPL v2 with class path exception license. And then we also have a commercial offering, which is for people who are looking for actual proper support and guarantees about when they get the updates and so on. In terms of our long-term support, we actually go all the way back to JDK 6. So we support 6 still, 7, 8, and 11. And then we've introduced what we call medium-term support. And we're doing that for JDK 13 and JDK 15, meaning we are still providing updates to those. And it's sort of a bridge to the next long-term support release. So you've got 18 months after JDK 17 comes out to migrate away from 15 to 17, for example. All of our builds are TCK tested, and I've put a asterisk there because technically not all of our builds are TCK tested. Reason being that JDK 6, because it's so old now, Oracle stopped supporting it, and that means there isn't actually a valid TCK that we can use for that. Everything else we do test. All security patches, all bug fixes, we backport from the current release, which is the one where Oracle make the changes, and then we backport those to all of those versions that we've just explained. And obviously that's where applicable, because if there's a feature in JDK 15, for example, that doesn't exist in JDK 8, clearly can't backport anything. We deliver our updates simultaneously with Oracle, and again, I put an asterisk there when I say simultaneously. If you look at our track record over the last couple of years, all of our updates have been delivered within 60 minutes of Oracle. I think the fastest we did was 22 minutes. The slowest was 59 minutes. So nobody's going to have enough time in order to figure out a vulnerability and exploit that vulnerability in less than an hour. We provide both a CPU and a PSU, same as Oracle do, and we have a full support organization that can do, problem resolution and things like that. Now, often I talk to people about that and they go, we've never had to call Oracle about a bug that we found in the JDK, so why would we want that? And I kind of thought to myself, yeah, probably you don't want to do that. But when I look at our support organization, I look at the customers that we have who are actually ringing us up and reporting problems that they find in things like G1 and CMS and stuff like that. And our engineers are actually fixing those and then upstreaming the fixes that we make into the OpenJDK projects. So the idea is maximum security, maximum stability, maximum flexibility. And that's it. 10 minutes. I think that was about it.
All right, excellent. Thank you, Simon. We'll take a quick question from the audience while we're waiting for Chris to get his share back up or get his share up.
Okay.
So, Chris, you're able to share. You're on mute right now. So anybody have a quick question for Simon regarding Azul and OpenJDK?
Nah, I'm disabled.
Okay. Can someone give Chris the
Oh, there we go. I got it.
Chris, you should have it.
Yep,
Okay.
got it now.
Yeah, quick question for Simon, and then we'll have to let him go since it's a little bit probably past his bedtime. What time is it over there, Simon?
It's midnight.
Oh, okay. So it's still early. Still got time for 3 or more whiskeys before bed, right?
Tempting.
Tempting, exactly. So anybody have any quick question for Simon before we let him go? Nope. Okay. Thank you, Simon, for coming, and we'll see you soon.
Okay. I just would say one thing. I would love to come to an actual in-person Atlanta JUG meeting.
Well, can you? Is the UK and the US? Is there travel allowed between the two? I think there is, right?
Yes. Technically, I can now travel to the US. I just have to quarantine at home when I get back for 10 days, but I don't have to go into a hotel, which is good. So I can technically go to the US.
Right. So basically, what you've been doing for the last year and a half.
Yeah.
Fair enough. We'll see if we can get you over here sooner rather than later. Since things are hopefully in our 2 countries which are doing good in vaccinations is the situation starting to get better, right? So, all right.
Okay. See you later then.
Thanks, Simon. Bye.
Okay, bye.
All right, Chris.
All
you're
right.
Next, I'll let you take it away.
All right. Can you guys hear me?
Yep.
Excellent. All right. So I'm Chris Curtin. Today we're going to talk about sharding with Spring Boot. So first question I often get is, so what is sharding and why would I want to do that? The textbook answer is sharding is a scalability option where for either business or technical reasons, you can't do a pure horizontal scaling. And by pure, I'm not making fun of MongoDB here, but that's the one everybody thinks of. It's, cloud scale, just add more nodes to my cluster. So what are some of the common reasons why you'd want to shard? Ones that I've encountered in my career has been around data retention policies. So I've got different classes of clients that I want to store their data slightly differently. If I'm selling by transaction, so if my business model is, if you pay me more, I'll give you faster hardware, how do I do that in a way in which I'm not building out an instance just for you? And the last one is one that I've recently heard in presenting this to an internal group that somebody mentioned that they used to work with. It's about mean time of recovery for an outage. Reality systems go down, things go wrong. If all of your data is in one place, how quickly can you get your production environments back up? And sometimes the answer is to have lots of smaller things instead of one big thing so that you're up and running quicker. All right, so let's talk about the most common types of sharding. The one you used to hear all the time, and the one that when I was at Silverpop we built, is what's called application level. This is also sometimes referred to as routing. And the idea behind this is you have a dedicated deployment of your environment, whether you call it a cluster, a pod, an instance, and it is completely isolated. It can survive when the others are down. It's possibly even geographically distributed. Two ways to address this. One is where the network knows how to route. So something coming in at the edge looks at your URL and goes, I know how to send it to the right place. And sometimes it's old school brute force DNS where your clients go to pod1.mycompany.com. The second is at a database level. And this is another one that I frequently saw in my career, where what happens is you decide that you're going to have a single deployment of your service, but at your client level, you're going to route clients to different databases. So client A for all of your services is in the US East Cluster 1. For client 2, they're all in US East Cluster 2. And at that point, the Java tier, which is one of the examples I'm going to show you in a few minutes, knows how to route between the different databases. Now, the one that I'm implementing now, and that as we debated it internally turned out to be a really good solution for our microservices architecture, is one where you take the best of the database level, but you also enforce the microservice rules of controlling your own data. And the idea here is that every service determines how they're going to shard their data. Some services may look at the problem and go, I'm 99% read. I don't need to do any of this. I'm just going to put a really big cache in front of it and survive. Others look and go, wow, I've got these handful of clients who behave so different than everybody else. I want to put them on a different type of Amazon instance. So maybe it's a heavy compute versus a heavy memory or a heavy I/O. And again, here the Java tier knows how to route between the different databases or data sources. The interesting one about this is you don't have to share the underlying database clusters between your services if you don't want to, but it allows you to. It allows you to say service A and service B are in the same cluster, but next week, because of capacity reasons, I can take service B's data and move it to a completely different cluster, and nobody is any the wiser. So how's this all work with Spring Boot? So Spring Boot has this really interesting class, and I'll show you an example in a second, called an abstract routing data source. And the idea behind this data source is everything in Spring, when you go to request a database connection, winds up routing through this class. And what this allows you to do is before you hand back a connection to any of your Java code in Spring, it intercepts and says, where do you want me to get the database connection from? In the example I'm going to show today, we're going to use a context holder, which is a thread local, which holds the shard key. But if you're doing reactive or you're doing some other technologies, there's things besides thread local on how to do this. In the demo today, I'm going to show off data sources that are hard-coded. So at startup time, you specified, hey, I have shard A and shard B. But I'm also going to give you some suggestions on how to do this using Spring Cloud config so that when a new shard is brought online, you don't have to go into your code and make a change. Instead, you bounce your service and Spring Cloud config suddenly makes a new data source available. So let's get to the part everybody loves. Let's get into some code. Can you guys see the code? You can see my IntelliJ? Okay,
Yes.
excellent.
Yep, we see it.
Okay, so here's by far the dumbest controller that I have ever written. And it's a simple REST controller. And in my request for getting the list of users for this tenant, I call something called setup context, which for now, really dumb, looks at the tenant and says, if your tenant starts with A, I'm going to send you to the primary. If it starts with anything else, I'm going to send you to the secondary. Again, really dumb, but the idea here is that in the simplest case, you can use this routing data source without having to get into anything very complex. Now, again, this is probably the simplest one you'll ever see. Reality, what people build are these interceptors. So here's an interceptor that sits as a once per request filter. And when the request comes in to do the filter, it actually looks at some headers. So instead of hard coding in every one of your controller, if organization's equal to A, send them down this path, we get it out of the header. And then, and I'll talk some more about this in a minute, we do a non-trivial lookup for what shard this organization should be part of. Now, in some implementations, this could just be a local cache. In one that I'm working on, we actually make a call to another REST service to allow us to change where a location of a shard is without having to reboot the service that knows about the shards. But the idea here, again, is we set this current context that says, here's the shard I want to route you to. Let's take a look at what this is. So again, dirt simple thread local. Yeah, I know thread locals have issues in depending on how concurrent you want to be and if you're going to be reactive. But for the general idea here, it's pretty straightforward. When you figure out what the shard is, you call set, and eventually you call clear. I'll talk about this one in a second. But let's get to the magic. Now that you get the idea, we've intercepted the request. We figured out for this tenant what their shard name is. And now we need to help Spring figure out where my data sources are. So again, real simple Spring configuration class. For this app, I've got two hard-coded data sources. And here's an interesting note that we learned as we rolled this out and realized we weren't seeing any of our micrometer. Doing this little trick doesn't actually register your classes with micrometer. You have to explicitly say, hey, I've created this new Hikari data source, and I want you to start monitoring it micrometer, and thus, in our case, Prometheus or whatever your downstream is. But here's the magic. So you define your data source. We gave it a name as part of this test, but you don't have to. You can just define your bean that has a data source. And inside your bean, you specify what your data sources are. So if you remember in the example I was showing over here, actually it's this one, apologize. We're setting this thing to primary. Well, how does Spring know about that? You've created this new routing data source, and I'll show you an implementation of that in a second. And you've said to it, hey, here's all the data sources that are available to you when Spring asks me for a connection. So let's jump into this guy, because this is where, honestly, the most boring part of this demo is, but this is where the magic is. So this is an implementation of the abstract routing data source. When Spring instantiates the beans and tries to go and get a database connection, it'll eventually call this lookup current key. And in this implementation, we go back to the context holder and we get the current database. I'll talk more about this interceptor in a second, but the idea now is we have told Spring, hey, for this particular transaction, use this database name. And when I jump back over here, you can see where I created the two data sources. Now, of course, this is the simplest case by far, but the more interesting things start to come in when we start thinking about doing this dynamically. So if any of you have ever tried to implement a read replica, the biggest question becomes, well, how do I figure out, without putting everywhere in my code, yeah, I need to use a read replica? So the routing data source, because it intercepts every request, allows you to take a peek at what the developer is actually intending and figure out the data source. So for example, at transaction read only. By defining your shard not to be a connection, because that looks, you see writer right here, that's a regular Hikari definition. Instead, you define your shard to be readers and writers, each of which has a connection pool. Now, when I'm in this class, I can ask the question, hey, what is the current transaction? Is it read-only? And in this case, by using an interceptor aspect with an interceptor looking for, where is it? Transactional, I'm able to detect that, wait a second, this is a read-only transaction. And as such, give it the secondary, which in this example is the read-only replica. So I have made no code changes in the business logic that consume this, any of my Spring Beans, any of my other controllers. And now I'm able to use a read replica. Last interesting thing to talk about here is, when I come back over here, because this is through Spring Cloud config, I have the ability to define lots of these and then allow my business logic to look at my data sources and, if necessary, iterate through them. So go look at the Hikari pools, which is the pool that's getting hit the hardest. To look at a specific reader. Actually, hold on, back up. Hold on, I meant to show something else real quick. Look at the requests for a read replica and then decide, wait, do I actually want to do that? I apologize, I got out of order in my presentation there. So here's a little thing that we introduced called a dirty read. Sometimes read replicas are delayed by a few seconds. Hopefully not minutes, but sometimes a few seconds. So in the same logic, we've introduced an annotation that basically says do a dirty read. Even though I'm in a read-only transactional request, skip it and go directly to the original writer because I think I've got some latency. So for 99% of my requests, this isn't a big deal, but maybe I'm doing something where I really need to get to the reader. To the writer. So basically, that's what I wanted to talk about. It's a pretty cool way of not having to change your business tier, but still be able to support read replicas and scale in a way that doesn't require you going to Mongo or some of these other web scale technologies. I have no idea how I did on time.
No, that's good. So yeah, I have a quick question while we get, hold on, let me just check who our next presenter is. David Morris. So David, if you could go ahead and share your screen and get set up while we take a question or two for Chris, we'll get going with the next one. Actually, there's a question from the audience. Okay, so the first one is there sample code in GitHub, Chris?
I do not have any up there. I can look into it. Most of the examples around sharding wound up coming from research in, I think it's Baludg, B-A-L-U-D-U-G. Those guys are great. We took a couple of different examples from them and put together the solution that I just presented.
Okay, excellent. And the second question from Jason was, what if you want to search across all databases? Is that possible?
Yeah, so I didn't show a lot of the details on the way in which the Spring Cloud config works, but because you're injecting a bean that contains all of the definitions, not just relying on Spring to figure out all the Hikaris and hide them in the magic of Spring, you have the ability to iterate through that bean and say to each shard, which is itself a bean, give me your reader, give me your writer. So you can write code that starts with, hey, I'm going to go ahead and iterate through all of my connections and I'm going to run this particular query against them. Now you're bypassing Spring's automatic give me a database connection logic, but there is a way to write code that knows that you're actually bypassing Spring and going directly to the data sources to get your hands on the connections.
Okay, that sounds good. And that's all the time we have questions for right now.
All right.
We want to get to the next presentation, but you can ask any of the presenters the questions at the end once we've gotten through everybody. So you can stick around for that if you like. All right, thank you, Chris. Great presentation. And now let's move on to David Morris, who is a senior architect over at Leidos. Leidos. How do you say that thing?
Hi, how are you?
Leidos.
Can everyone
Good.
see my screen?
Yep, we can see your screen. So,
Look,
David, are
listen.
you local to Atlanta?
No, I'm not. I'm up in the Baltimore, Washington area.
Baltimore. Gotcha.
Yeah.
Awesome.
I could
Okay.
just do a quick story how I found you guys. So not too long, I think back in March, Oracle had the 25th anniversary conference. I don't know if anyone here attended. It was online. And one of the things that they're talking about was the pattern matching. There was plenty of topics looking for Java users groups, and I was trying to find out which one I think is close to where I am, and probably one of the better Java users groups. So I picked you guys. So this is my first time presenting and first time attending one of your user group meetings.
No, well, welcome, David. I do know that there is a Montgomery County user group. I assume that's up near you.
Yeah, that's
in the
near
Baltimore
where I
area.
live. Yeah. So
yeah, so there's a good user group up there. I can't remember the guy's name who runs it, but anyways, it's worth checking that one out too.
Yeah. So
we can see your screen. So please go ahead and get started with your presentation.
Okay, great. Okay. So the topic I picked was the Java 14 pattern matching for instance of, and the reason I picked this one was because I've been a Java developer since 2000, and I'm sure with all the code I've written over the years, every once in a while you have to use instance of. You can't get around it. So I've written quite a bit of instance of, and so I was interested in what Oracle, what they've done with the OpenJDK. What are their plans for maybe reducing some of the boilerplate? Because if you've written instance of, you would notice there's quite a bit of boilerplate with the code, and then see what they have done. So when Java 14 is out, the instance of operator, they extended it to take a type test pattern instead of just type. So you notice before Java 14, you'd have to write code, for example, as object instance of string, then take the string and then cast the object to a string. But now with Java 14, it takes a lot of that boilerplate out. You can just, within the command line on the if statement, you can just say object instance of string s, and it instantiates the object s. So I thought that was an improvement. Not necessarily make your code run faster. I think it's more readability for the developers. Less code, I think, is better. More concise code, I think, is better. If you get your point across, if they don't have to read all this boilerplate over and over again, it solves that problem. Also, you may reduce errors because you're not going to get a cast class exception if someone goes in there and does something funky. So you kind of try to avoid those errors. So I thought that was an interesting feature if and when this gets implemented. I'll get into in a minute. And the other thing they added was they applied a condition with the double ampersand operator. So not only can you say as an object instance of string, you can say object instance string s, and you can say ampersand is a length greater than 5. So that would kind of make the code more concise and make it maybe easier for readability purpose. The one thing caveat is it does not work with the OR operator. So don't try that. It's not going to work. And I'm using Eclipse. Eclipse will catch it, so you won't even be able to compile it. So make sure you do that if you do use this. And again, this is a preview language feature in the JDK 1.4. It's not officially out there yet, so I wouldn't go take production code and then add this in, because there's no guarantee that this feature will be added. And I did look up, I know when the first presenter talked about OpenJDK. If you go out there on the OpenJDK site, it did find a reference which talks about what a preview feature is. So whenever you see Java and they mention preview features, this is what it is. It's a new feature, the Java language, the JVM, or Java SE EDGI that is fully specified, fully implemented yet fully impermanent. It's available as a feature release to provoke developer feedback. So this is kind of like provoking developer feedback is what I'm doing. I don't know if someone else is looking at instance of, looking at this, where they're, okay, is this worth having in the language or not? So it provokes developer feedback, and then based on real world views, and if I guess the OpenJDK votes on it, may lead to recurrent feature in a future Java SE. I think we talked about Java 8 and then Java 11 tonight. Java 14 is out a little ways. I'm not sure too many people are using Java 14. I know in my production environment, we are using Java 8 and Java 9. So we're not even out that far. And a couple things I've learned, because I'm trying to get this to work. Okay, this is great. This is kind of cool. So I was kind of playing around with it, and then trying to get it to work in Eclipse. So I have Eclipse installed. I installed the latest Eclipse on my machine, and I did notice a couple things that you have to do when you set it up in Eclipse. Notice I have to use JDK 1.5, which I thought was interesting because this is JDK 1.4 feature. Why do I need JDK 1.5? I'm not sure with Eclipse. I'm not going to go argue with Eclipse and find out why we need 1.5. Not only that, you have to use that, you have to enable the preview feature. So make sure that's enabled. So you have to enable the preview feature to get it to run and the release options. So it's kind of a little bit of a setup. And with that, I'm going to jump right into code because everyone wants to see code. Let me go into code real quick. So I had a few examples that I put together, and then I talk about. You'll notice I have a couple methods here. I have a print length, and I overloaded it, and I have another print length with string. And what I'm going to do is I'm going to run this, and it's print length of LA, print length of Washington, and print length of a list of. And using the new instance of invoked the method, the variable is invoked here, so the string. I don't have all that boilerplate. I don't have to cast it. And then I call print length. Then I have another one where I will show the example with using the ampersand. So it's the, okay, is the object instance of string? It is. Okay, check this free. The string length is greater than 5. And if it is, length is greater than 5. So very, very simple examples. And then I have a list here just to show what list is and iterate through the list. So let me go ahead and run this real quick. And so you notice down here I have printed out. So this is kind of what it does. Generally, when I code, I usually put examples together first, check it out, make sure it works, and kind of understand what it's doing. The only thing I think it helps the developer is we do cut down on that boilerplate, so we have less of that. The question is, I guess, if you go in production environments, do you want somebody to go back through all your code, remove all that boilerplate, and put in the new feature? So that's something, I guess, developers and the product managers have to decide whether that is worth doing. But that was one of the things I got out of that Java 25th conference. They talked about several things. I just happened to pick this topic because that was kind of interesting when I was looking into. That pretty much concludes my presentation. If anyone has any questions, let me know.
All right, thanks, David. Definitely the improvements in the instance of with the new versions of Java is pretty cool. It has some loses a lot of the verbosity for sure. So while Summers Pittman is getting set up to give his lightning talk, does anybody have a quick question for David? Is Summers still here? Hey, Summers, you still there?
I think I am. Am I still here?
Yes, we can hear
Awesome.
you.
All right.
Hey, David, can I ask you a quick question?
Sure.
Hey, if you go to line 13 on your IDE in Eclipse, just wanted to understand. So I guess it does not, and it makes sense, I guess, but does not handle the sort of the genericized version, right? So, you know, it would be cool if you could say object instance of list of strings actually. Generic.
Yes, that was one of the things I was looking into. So yeah, it's like add a type argument. Yeah. I don't think
Yeah,
I
I
don't
guess.
think it allows you to do that. That would have been kind of cool, but that is a defect. I don't know if say it's a defect, but yeah, you'll get this kind of issue. I
Yeah.
tried doing that to kind of clear up some of these warnings, but Eclipse doesn't recognize it, and there's no way of doing that.
Cool. Thank you.
But that's a good catch.
Okay. All right, Summers, go ahead and share your screen and we'll get you going.
All right. It's saying that the host has disabled attendee screen share.
We can see it.
Okay.
Stop share. Okay.
Oh, oops, sorry. I saw something.
Where's Summers? Yeah, you should be able to share, Summers.
The host has asked you to start your video. All right.
Well, let's start with that, and then you should be able to screen share.
All right.
I just made you co-host, Summers.
All right. Select window or screen. Yes, yes, yes. Okay, let me find. All right. Do you see my screen?
Yep.
All right.
Go.
Sweet. Hi, my name is Summers Pittman. I'm a software engineer at Red Hat, and this is my talk, Java Records in a Flash. Java Records are a new feature available in Java 16 and have been in preview since Java 14. If you want to know more beyond what is in this talk, I recommend that you check out JEP 395 and the Amber mailing list. These resources cover records and their designs with much more depth than I can do in 10 minutes. This is a lightning talk after all. Records are a whole class in as little as one line of code that define a named tuple with immutable data. In this example, we define a record point with fields X and Y. Java implements for us the equals hashcode, toString, accessors, and a canonical constructor with the method fields as parameters. Records do have some restrictions that don't apply to normal classes. Records are immutable. They aren't allowed to have instance fields other than the record parameters. They may not inherit from other classes, nor may they be extended by other classes. Fields are private and must be accessed through accessors, and serialization cannot be customized. JEP 395 covers these restrictions in more detail. Otherwise, records behave as normal Java classes. You can instantiate them with new, print them with toString, compare them with equals, and use them as keys for maps, etc. Because the JVM implements equals and hashcode, you get a lot more reliability when using records as map keys. In this example, we create 5,000 record instances, but there are only 256 unique values, and we then use them as keys in a map. In a traditional class implementation, the class's default hashcode and equals methods would create a map with 5,000 unique entries. However, when we're using a record, we get the correct 256 numbers of entries that we would logically expect. Another feature of records is that their parameter names are encoded in their bytecode. This means that tools such as Jackson can use records to marshal and unmarshal JSON data without bean pattern accessors, field annotations, or constructor annotations. In this example, our point class is packed to the Jackson object mapper, which reads in data in JSON format and transforms the JSON file into point objects. We can then stream this data out and print it using the generated toString method that the Java record provides. It's worth emphasizing just how much code you actually have to write to do all of this correctly in Java. Our point record requires a single line of code, but the classical equivalent of this code doesn't even fit on a single slide. While we can use an IDE to generate most of these methods, it's very easy to introduce bugs into our code. For example, if we add a field to this class, we would suddenly have to use our IDE to regenerate equals, hashcode, and toStrings, but with our records, these methods are regenerated automatically. Records can also be declared locally inside of a function. In this example, lifted straight from the JEP, we are sorting merchant objects by the number of sales they've had in a month. We define a local merchant sales record with a pair of values, the merchant and their monthly sales. This method maps the merchant instances to the merchant's parameter in the merchant sales record using the generated canonical constructor. Our streams then sorts these instances by sales, extracts the merchants from these records, and returns them as a sorted list. The benefit of this is that we haven't created an extra class file, and the overall code is cleaner than if we had used traditional classes. Records also support generics as well. Here we have an example of a simple pair that accepts any two values. These values can be accessed using the accessor methods first and second. This pair can be used as a key in a map, marshaled to JSON, printed, etc., all in one line of code. If you have a situation where a method needs to return multiple values in one object, then a record may be more useful than creating a class. A more in-depth example of this is in the Go language. It's common to have a return value that returns the return value and also an optional error if there is a problem in processing. A Go program would then check this error value and see if it's defined, and if it is, handle the error. In Java with records, we can recreate this pattern with a record class holding two generic parameters, a value generic type of any object and an error generic type that's been bounded by the exception type. In this example we read a file and return a record with a string and null if the file is read successfully, and null and then the exception if an exception was thrown during the reading of the file. This is useful if throwing an exception isn't an appropriate action for our code to take, or if we're doing batch processing but we don't want to lose exceptions that occur, or if we're just porting Go code to Java and we don't want to refactor it. Records also introduce a new type of constructor, the compact constructor. A compact constructor implicitly has parameters which match the record's parameters. The compact constructor's parameters are automatically assigned to the record's parameters at the end of the constructor body. This is useful if we are validating or normalizing inputs. In this example, we have first and second. Well, it should be X and Y. That's an error. But anyway, if the first parameter is null, then we throw a runtime exception that it can't be null. And if the second parameter is a string, we throw a runtime parameter that the second parameter can't be a string. Sorry about the error in my slide. An alternative is that we can actually enforce a range of values instead of validating data. In this example, we're using a color record that represents a 24-bit RGB color value with three int parameters, R, G, and B. In this color format, the maximum value of any single color component is 255. We've created a compact constructor that is given the R, G, and B parameters and clamped them to the value 255. So if they're over 255, they're just set to 255. But if they're under than that, then they get set to the value that we provide. After this block is executed, Java assigns the parameters in the compact constructor to the record's R, G, and B fields. Records can still have traditional constructors. They must be set to the record fields or delegate to a constructor, which is the same as the case with any other final fields in traditional classes. In this example, we've created a constructor that doesn't consume two parameters like the canonical constructor would, but instead it consumes a map.entry value. It destructures this entry into the key and value and assigns them to the first and second parameters respectively. We can then use the Streams API to transform a map class into a list of its parent values. Records also generate accessor methods on their fields automatically. Record fields are private and your users will only be able to access them via accessor methods. These are named following the pattern field name, then parenthesis. Importantly, they do not follow the bean pattern of get field name and then parenthesis. We can still override them as if they were traditional methods, and this lets us log access, modify return values, and so forth. In this example, the first accessor method logs access to it with a message to standard out. Remember that equals and hashcode methods generated by Java use these fields directly. So if you change the value that you're returning in your accessor method, you might want to update your equals and hashcode methods to use the accessor method instead of using the raw field. Otherwise, the user might see their accessor method return one value, but have their equals or hashcode methods fail. Records can also have instance methods. They aren't allowed to change the record fields, but they are useful for performing transformative operations on the record data. Here we've implemented a method that merges two pairs into a pair with two lists. Other use cases for instant methods in this pattern would be mathematical operations. If, say, for instance, the big decimal class, which is an arithmetic, which is a similar pattern of immutable data that represents values, it has mathematical operations such as add. And when you call big decimal dot add with another big decimal, you get a new big decimal object. In records, you would be able to do something very similar, and that's what you're supposed to do with them. Going forward, records are being developed as the Java language evolved. In JEP 405 and 409, we have previews of two new features of records that are coming to Java in the future. The first is in JEP 405, destructuring of a record using the instance of pattern match that David was just talking about. So in this example, we have circle, which has a field radius. This radius value is destructured and is able to be used in the block after the instance of check. Additionally, we have JEP 409, which introduces the concept of sealed classes. Sealed classes let developers define the set of all implementations of an interface. Because the compiler will know how many implementations exist, future versions of Java will be able to confirm that when adding implementations of classes, you don't break any legacy code at compile time. Records can be used as data holders, and the default methods on the interface can safely provide comprehensive implementations. In this example, we have defined a shape interface, 3 record implementations, and a default method to calculate the area based on the type of shape we're using. If we were to add a new shape record interface implementation in the future, until we add to the switch statement a case for that new record type, then it will be a compile error in Java. Anyway, thanks for listening. And if you want to know more about records, JEP 395 is an amazing resource. If you want to know more about me, follow my GitHub at Second Son or my Twitter at Summers Pittman. And finally, have a great night. And thank you, AJUG, for hosting this talk.
All right, thanks, Summers. While Abhishek gets his screen share going, we can take a question or two for Summers about records. So Abhishek, go ahead and try to share your screen and turn on your camera and your microphone so we know you're out there.
Sure. Hey, Summers.
Okay.
This is Shyam.
There we go. So anybody have a quick question for Summers on? Anybody have a quick question for Summers on the records?
Yeah, hi, this is.
Nope. Yeah, Shyam, go ahead.
So the records, right, is a kind of a replacement for a Lombok data library, right? So basically, it completely removes the data need, right? Is it correct?
Sorry, I heard records are a replacement for Lombok, and then you trailed off there.
Annotation at data library, annotation at data component, it completely, that's what the Lombok library provides, right? So basically this completely removes that, right? You don't
yeah, Lombok does, using annotations, a lot of similar things to records. Lombok offers more features than records does. I'm not familiar enough with the library to actually list everything they do versus records, but I know that Lombok does have more features than records do.
Okay, so why don't we take the rest of that conversation for the end, which is right after Abhishek Mishra's presentation. So Abhishek, you're here in Atlanta, right, Abhi? You're on mute, buddy. Abhi, you're on mute. Yep. Let me ask to unmute.
Yep.
Okay, there you go.
I didn't want to disturb Summers.
That's all right. So you're here in Atlanta, right, Abhishek?
Yep. So I am here in Atlanta. I work in OneTrust. That's in Sandy Springs.
Okay, cool.
Yep. So are you guys able to see my screen?
Yep, we can hear you and we can see your screen. So take it away.
All right. All right. So I'm Abhishek. I work at OneTrust, been there a year. And if you guys are in Atlanta, you might be following the OneTrust story. Like we grew like within 4 years, we have grown to like about 2,000 people. And our technology stack has also grown crazy. So in this talk, I'm going to talk about running a Kafka Streams application in production. I'll, if I can. Yep. So I'll take one example use case, and then we'll be using typically use Spring Cloud function with Kafka Streams binder. So some of the code that I show might have references to those. There are scenarios where we are supposed to be counting events by a key, and we are and in a distributed application where multiple instances of an application are running. So typically, like for rate limiting scenarios or quota scenarios, or let's say in this example, if you want to count crash logs by an app ID and you want to raise an alert if it crosses a threshold, and your crash logs are coming to different instances. So you want to be counting, but you have to use a distributed cache. And if there is a very high load scenario where you cannot afford to, like for each event that is coming, go to a distributed cache, remote cache, and update or compute. So that's the kind of scenarios where we can use Kafka Streams library. So basically, Kafka Streams will let us do the computations locally. So distributed computation, but still let us do it locally. And we'll go through how. So quick concepts about Kafka. Pretty much everybody should be aware, might be aware of these things, but just since they are related. So events in Kafka are nothing but messages. Topics are the addresses where these events go. Right, so it's a logical grouping of those for those events, and partitions are how we scale the consumers on the scale the topic consumers. So for example, if you have 1 million messages coming to a Kafka topic, you might create like 10 consumers, and now you can have like 10 partitions, I'm sorry, and now you can have like 10 consumers, each of them tied to one partition each, and now you can in parallel process all those 1 million messages, right? Kafka Streams library does use partitioning, so that's why I just went through that quickly for Kafka. So Kafka Streams library is a client library that you typically embed in your Java application, and it's by the same folks like same Kafka folks. So what it lets you do is it has concept of like source, sink, and processors. So what it lets you do is you can tie your Kafka Streams application to a input topic that will act as a source. And now you have a stream of messages coming from, now you get a stream of messages from that input topic. And on that stream, you can apply like Kafka Streams DSL methods, like you can do filters, aggregations, counting, and stuff. And then after your computation is done, using the sync construct in Kafka Streams, you can post any result that you want on a new Kafka topic. The way it works is it will create an internal buffer of messages from the Kafka topic, and then it will let you do one record at a time processing using specific constructs like stream and stuff that we'll talk. It also lets an application instance hold state, and in a fault tolerant way that like even if the application instance goes down, your state is still can be recovered, and the Kafka Stream library handles that. Right, so this is one example aggregation code. Sorry, I should have probably got the IntelliJ going here, but and I cannot click the mouse. So in the first line, you have a K stream object that you create from an input topic. And in the next set of lines, we are seeing that on the input stream, you can apply methods like you can filter on those methods. So if some messages have to pass a criteria before you process them or count them, you can put those there. And then you can do a grouping on them. So group by key is a way for you to group messages in a topic by whatever key is there in that message. And on top of that, you can apply windowing. So for example, if you want to count like for a given application ID, give me the number of events that I've received for a given app ID or whatever key you choose for a key, and give me a count of events every hour. So you can do something like group by that key, count them, and then get the count by an hourly window. And we'll see how internally that counts are stored in Kafka streams. So some of the main constructs in Kafka Streams library is the K-stream. So K-stream in here basically when you create an Kafka Streams enabled application, the number of instances that you instantiate for that application will be equally tied to a Kafka topics partitions. So for example, if you have a Kafka topic with 3 partitions, now you can create like 3 instances of the Kafka Streams application, and each one of them instances will tie themselves to a partition. And Kafka Streams has an internal construct called K-stream task. So for each partition, a new K-stream task is created, and it's always tied to the same partition. So if you took care in sending your messages to your Kafka topic by a partition key that will also be your group by key, then you can assume that your app one, for example, in this example, app one will always have all the data for a given key, for a given group by key. So you can safely put like get a K-stream out of this and then do a group by on the key of these messages in partition one. Okay. Internally, when you are doing something like a count that you saw in the code example, so the counts will be stored in what is called a K table, and these counts are tied to the specific partition, and the K tables are backed by what is called RocksDB in Kafka, and they will be stored on the disk. So for example, if you're doing an hourly aggregation, an hourly count of messages, right now, let's say if you are in the 8 to 9 p.m. hour, right? So you'll have a primary key created, which will contain the group by key by whichever the group by whatever you are grouping by, and the time windows 8 to 9 time window. So let's say if you within an hour you read it 10 times, then your K table will have one record with that particular group by key and the time window as primary key and the count. And that count will keep getting updated every time the Kafka stream is processed. Then there's a concept of global K table, which is similar to K table, but the major difference here is the data in global K table comes from all the partitions of a topic. So typically when you have scenarios where you want, you have a cache or you have an entity that you always want to join, like use to enrich to your incoming stream, then you would want all your app instances, in this example, app 1, app 2, app 3, to have access to that data from a topic. And even if that topic has like 3 partitions, you want all the data to be available. So in that scenario, you'll be using a global K table. So in our scenarios, if you have a if you're doing like grouping by app ID and you want to raise an alert whenever a number of crashes for a particular app goes beyond a number, so this is the design that you can use. So you have an event publisher where which will publish events to a Kafka topic, the first one. There you can use the aggregation, you can use the partition key as the app ID as the partition key. So now every single unique app ID's data always goes to the same partition. And then at the bottom, you have 3 aggregated instances of a Kafka Streams application, which will tie themselves, each instance will tie itself to one partition each. And then you'll be counting. So you'll be grouping by the app ID and doing a count, windowed count. And on the right side, you have a Kafka topic, which is being used, will be used as a global K table. So let's say there you could keep like for each app ID, how many crash logs you want to allow before you raise an alert, right? So for that app ID, you could have that configuration could be kept there, right? So now in this Kafka Streams application instance, you can do a join between the K stream that you're reading in aggregator 1 and the global K table. And using that join, if you ever, whenever your count is going beyond that configured number in the global entity, you can raise an alert. So this kind of things, this kind of setup could be used for doing rate limiting, doing quotas for in a multi-tenant system. If you want to do quotas for tenants, that this kind of system can be used without putting like a remote cache where you have to go and do an atomic update and atomic count. There are some quirks in using Kafka streams, like there are some irrecoverable exceptions where you'll end up with this kind of error message, like all stream threads have died and the only way out is the restarting that application. So we had the issue as well, and we use Kubernetes in our deployment. So what we did was we introduced like we use Spring heavily, so we have Spring actuators and we have health endpoints with Spring actuators coming. So what we were able to do is add Kafka binders as the health check parameters. So now if in a Kafka Streams application, the health check will include like Kafka Streams status as well. So in this JSON example, you can see the K-stream status is also included. So if the K-stream is down, and if the K-stream is down, you are aware of it. And in the Kubernetes system, you have something called a liveness probe, liveness and readiness probe. So you can tie your liveness probe to this health endpoint, and and also configure it in a way that if this health endpoint is down for, let's say, 10 minutes, then you just let Kubernetes system kill that application instance and restart it. So that's what we do, and that's how we, like, you never have to touch that Kafka Streams applications manually. There are some do's and don'ts. I don't know how much time I have left. So yeah.
Yeah, we should probably wrap it up in the next minute or two, Abhishek.
Sure. So yeah, this is my last slide. So yeah, in the group by key that we saw, that code that we saw, the aggregation key that the group by field that you'll be using for the aggregation, it's if you don't have if that key is not part of your Kafka message in the topic, Kafka Streams will internally create a topic and then route all your particular whatever you're grouping by to a specific partition. So you should avoid like creating a it's better if you know what's your group by key, then you decide that upfront and use that as a partition key on the input topic. Since the K tables are created on the disk, you should include a retention period for these K tables. Otherwise, you'll have like for each hour, the count data will be there. So there are ways you can say, okay, delete this after a day, and those records could be purged and you still manage your disk space. And the commit interval, like whenever these K tables are being updated, you can manage that. So your disk IO is manageable as well. So you can do something like every minute update my count, or every 30 seconds update my count based on how critical your load is. That's about it. Yeah, if you have any questions, please let me know.
Okay, thanks, Abhishek. That was a good presentation. Does anybody have a question or two for Abhishek before we move on? Just go check the chat, see if anybody has anything. Nope. Okay, so those were all great talks today. Thank you, everybody. Simon, Chris, David, Summers, and Abhishek for presenting. As I said earlier, we're probably going to consider moving up our in-person meeting to sometime sooner rather than later. So if you have an idea for a presentation that you'd like to give, well, whether it's virtual or in person, doesn't really make a difference. You should consider that. Let us know by sending us an email at info@ajug.org.